Now, next is here Le-Chatelier's principle. Le-Chatelier's principle. Le-Chatelier's principle. Now, what is Le-Chatelier's principle? First, you write the principle. If a system in equilibrium is subjected to stress, stress means in bracket you can write change of concentration, temperature, pressure, etc. If a system in equilibrium is subjected to stress, change of temperature, pressure, concentration, etc., then the equilibrium shifts in that particular direction. So as to counteract the effect of the stress imposed. Again, I repeat. If a system in equilibrium is subjected to stress, in bracket you will write change of temperature, pressure, concentration, etc., then the equilibrium shifts in that particular direction so as to counteract the effect of the stress imposed. So, this is your law. Now I'll explain it. Suppose an equilibrium reaction is there, any particular reaction is there. Alright, like suppose we are having N2O4 gas, reversible sign gives 2NO2 gas. Now, what is being said is that if a reaction in equilibrium, this is a reaction in equilibrium, is subjected to stress, means you are changing the concentration, you are changing the temperature, you are changing the pressure, whatever it is, you are doing it. Then the equilibrium will shift in that particular direction. This equilibrium, either it will shift in which direction? In the forward direction, or it will go in the backward direction. There are two directions only, either forward or backward. The equilibrium will shift in that particular direction. So as to counteract, you have to understand this word, counteract. Counteract means so as to, what you can say, negate it. Alright, so as to cancel the effect. Alright, so as to cancel it, so as to negate it, so as to counteract the effect of the stress imposed. Means suppose this reaction you are increasing the concentration of N2O4. Then what will happen? If you are increasing the concentration of N2O4, then the reaction will move in forward direction. That is, you are going to get more of NO2. That's it. That is what the Le-Chatelier's principle says that. That is called as a counteract. Alright, so if a system in equilibrium is subjected to stress, change of temperature, concentration, pressure, etc., addition of inert gas, catalyst, so many things are there, then the equilibrium will shift in that particular direction. So if I increase the concentration of N2O4, what is happening? The equilibrium will shifting in the forward direction. That's what I say. The equilibrium is going to shift in that particular direction so as to counteract, means so as to negate it, so as to cancel that particular effect. The equilibrium is going to shift in that particular direction. We can say that. Clear? So this is called as a Le-Chatelier's principle. We can say that. Now you can see that the principle looks very simple, but there are enormous applications are there in the Le-Chatelier's principle. Let me tell you, the entire industrial chemistry depends upon your Le-Chatelier's principle. We can say that. All the processes, it depends upon the Le-Chatelier's principle. You will be studying it when you will study in the higher classes regarding this in the upcoming chapters. When you will be studying, you will be coming to know what is the application, what is the use of the Le-Chatelier's principle. You will get it, then you will understand it. Now let us discuss one by one the points. Now the first is your effect of concentration. Already just now I said it, effect of concentration, that is change of concentration. I already said you, if you increase the concentration of the reactant, the reaction will favor in forward direction. If you increase the concentration of the product, the reaction will favor in backward direction. Alright, that's counteract. Alright, if you are increasing this concentration N2O4, then more of NO2 will be found. If you are increasing more of NO2, then more of N2O4 will be found. Alright, in this way. Now, to understand this, we will see some practical examples. We will see it. Now, let us say that we are taking, ferric solution, we are taking it, which is pale yellow color, ferric ions. Ferric solution we are taking, let it be a ferric chloride solution I am taking. So, it is pale yellow colored solution, let us say. Now, this is being added to a thiocyanide solution. Thiocyanide, that is SCN. Now this is a colorless solution like potassium thiocyanide or ammonium thiocyanide. Alright, I'm just taking the ions. Now what will happen is that you will see it will be FeSCN, that is something but 2 plus. How it is? 3 plus 3 minus 1 plus 2. Very simple. Alright, so you will be getting FeSCN 2 plus. Now this will be blood red in color, dark red colored solution, you will be getting it. blood red colored solution, dark red colored solution. You can say in certain books it is also being written reddish brown colored solution. No problem. It is also reddish brown, dark red, blood red, anything you can say that. Ultimately the color is going to change. Fine. So if you are adding more of ferric chloride to this particular solution, to this particular equilibrium mixture, then you will find equilibrium is favored in forward direction. That means this becomes more blood red. The product you will see, it becomes more blood red. If you are adding ferric chloride solution to it, you will see the equilibrium favored in forward direction. How do you know it is equilibrium is favored in forward direction? You will see the solution becomes more dark red, blood red, or whatever you can say, it is becoming more darker in color, you can say that. Got it? Fine. Now, suppose if you are adding, let us say, similarly if you are adding NaSCN, sodium sulfocyanide, if you are adding, same thing will happen, the equilibrium favored in forward direction. So you are increasing in some way, you are increasing the concentration of the reactant, the reaction is favored in forward direction because more of the product is being formed now. If you are adding more of ferric chloride, so more of Fe3 plus ion you are giving, so more of the product is being formed, definitely. Fine. Now next is, if you are adding a small amount of potassium ferrosulfocyanide, which is capable of giving FeSCN 2 plus ions. Potassium ferrosulfocyanide, which is capable of giving FeSCN 2 plus ions. That means the concentration of the product is increasing. In short, I can say, what will happen? You will find that the intensity of the red color is going to decrease. Got it? Intensity of the red color decreases. Why it decreases? Because the equilibrium is favored in backward direction. Understood what I said? You are adding potassium sulfocyanide solution. Got it? Potassium ferrosulfocyanide solution. Sorry. Then what will happen is that it will give you FeSCN 2 plus ions, ferrosulfocyanide ions it will give you. Now due to the increase in concentration of the product, what will happen? The reaction will favor in backward direction. How do you know the reaction is favored in backward direction? The intensity of the blood red color decreases. By this we come to know the reaction is favored in backward direction. Similarly, addition of mercury chloride. If you add mercury chloride to this particular solution, what you will find is that it decreases the concentration of SCN minus ions. Because mercury chloride reacts with SCN minus ions to form HgSCN minus, 2 minus, we can say that. Clear? That is mercuric sulfocyanide it is going to form. So by a decrease in HgSCN whole twice or 2 minus, we can say that in terms of ions, we can say. So what do you find? A stable complex compound is being formed. We can say that the equilibrium gets shifts in the backward direction, because if this is being used up, that means, see, if the concentration of the reactant is decreasing, because what I said, by adding mercury chloride, this is being used up because it forms HgSCN whole twice or HgSCN 2 minus ions it is going to form. Alright. Due to this, as the concentration this is going to use up, in other words, what I can say, the concentration this is going to increase, the product is going to increase. So the reaction will favor in which direction? Backward direction. Again, the intensity of the blood red color decreases. I hope you are getting it. So in this way, by increasing the concentration of the reactant, the reaction will favor in forward direction. If you increase the concentration of the product, the reaction will favor in backward direction. Or if you decrease the concentration of the reactant also, in other words, you are increasing the concentration of the product. In that case also, the reaction is favored in backward direction. We can say that. Clear? I hope you understood that. The effect of change of concentration. Now, this is how it affects in our day-to-day life. Can you give some examples that the effect of concentration affects in our day-to-day life? Yes. For example, clothes dry quicker when there is a breeze or we are shaking. You have seen it that the washer women generally, got it? Many washer women, what they do is that they big saris which are there, how they dry it up. That is, before putting the saris on the ground, not a wet ground, of course a dry ground where the leaves and the grasses are there. Otherwise the sari is not going to, what you can say, not only it's going to get dried up, but at the same time it is also going to become muddy and also unclean it's going to become. So what they are doing is that the two persons, one woman is holding at the one end and the other woman is holding at the other end, and they are shaking it up and down. By doing so, what they are doing it? They are, that is nothing but, that is drying up the sari, we can say that. They are drying it up. Alright. Or you can see it in your home also, your mother, when she is that is washing the sari and she is putting on the wire. Alright. So what she is doing? She is spreading the clothes. Even we are also, after washing the clothes, we not dump in one particular place. We spread the clothes. Why? Because by spreading the clothes, the surface area increases. By increasing of surface area, more of molecules gets evaporated in a lesser time, and hence the clothes get dried up quickly. So here what you find is that an equilibrium is set up between the wet clothes and the dry clothes. The reactant is wet, the product is dry. You want that the reaction should favor in forward direction. Wet to dry, it should go. So how it is being favored? For that reason, either you are taking the clothes, the two persons are holding it and they are that is tossing it up and down. Alright, clear? Or what it is that you spread the clothes and you dry it out, you put it in the wire or something like that. By doing so, what happens is that the surface area increases and more of water molecules gets evaporated and the reaction is favored in forward direction. That is, we want the product, the dry clothes, and we get the dry clothes sooner. That's it. We can say that. Similarly, we sweat more in a humid day. Got it? But it evaporates when you are sweating it under the fan. Why we are sweating more in a humid day? Because in a humid day already a lot of moisture is being present in the atmosphere. So the moisture does not get dried up from our skin, because already it is there already the moisture is being maximum in the atmosphere. Humid, when already the moisture is being saturated in the atmosphere. It will not absorb more of moisture from your body. More of sweat it will not take from your body. As a result, you will be feeling sultry, or you will be feeling, what you can say, jisko Hindi mein chipchipa bolte hain, you will be feeling it. Alright, in a humid day, if you are sweating. But if you sit under the fan, you will feel comfortable. Why? Because when you are sitting under the fan, the wind which blows over it, it favors the reaction in the forward direction. That means sweat gets evaporated from your body. Alright, the sweat gets evaporated from your body and the equilibrium is favored in forward direction, and hence it gets dried up. That's it. You feel comfortable. Alright. Similarly, the tooth decay also. Alright. By sweet things, when you're eating the sweet things, the tooth decay also takes place on the basis of the what you can say, equilibrium. We can say that. Now, you know, our teeth consists of an insoluble substance which is known as the enamel. Alright. Which is a very hard substance, you know that. Which is nothing but hydroxyapatite. The formula is CA5PO4 OH, hydroxyapatite. This is the name is hydroxy, that is apatite, PO4 whole thrice, sorry, CA5PO4 whole thrice. What I said, hydroxy, let me write it the name, hydroxyapatite. This is nothing but the enamel which is made up of. Clear? Now this will dissociate to give you, what is that, 5Ca2 plus, see 5, it is there, then 3PO4, that is 3 minus, 3 molecules of PO4 is there, the 3 PO4, 3 minus, plus you will get it OH minus. 1 OH is there, very simple, OH minus, fine. Now, what I find, this, the forward direction, if the reaction is going, that is called as demineralization. Mineralization. M-I-N-E-R-A-L, it should be demineralization. That means the enamel is being used up. Alright, that's it. And this is known as remineralization. In the backward direction, if the reaction is going, then it is a remineralization. Means hydroxyapatite is being formed, which is the enamel is being formed. And here the enamel decomposes. So generally when you take the sweet things, what happens? Sweet things contains H plus ions. Alright, sweet things, it contains H plus ions. H plus ions reacts with this OH minus ions. Alright, when it reacts with the OH minus ions, then the concentration of product is decreasing. If the concentration of product is decreasing, then the concentration of the reactant is increasing. If the concentration of the reactant is increasing, the reaction will favor in which direction? Forward direction. That means demineralization is going to take place. That means the tooth decay takes place. So for that reason, it's advised that you should not take so much of sweet things. If at all you are taking it also, you should brush your teeth immediately. Generally, the what you can say, the toddlers, we can say that, or the babies, or above that also the boys and the girls, that is, we can say that. Clear, the young boys and the girls, it is advised that you should not eat so much of chocolates or so much of this sticky things like ice creams and all those things, because it sticks to your mouth and it's in your teeth, and the demineralization takes place because the tooth decay, it takes place. Understood now how tooth decay takes place? Because whatever the sweet things you're eating, it contains H plus ions. These H plus ions reacts with the OH minus ions and the reaction is favored in forward direction. Got it? Due to which the tooth decay takes place, which is called as demineralization. We can say that. Clear? So this is all about your effect of change of concentration. Now already I said you effect of change of temperature. That is, if a reaction is exothermic, then the temperature should be less. If you want the reaction should be in forward direction. If a reaction is endothermic, then the temperature should be more. If you want the reaction should be in the forward direction. So always remember that exothermic reaction is favored by low temperature in the forward direction, and endothermic reaction is favored by high temperature in the forward direction. Because always remember it, if a reaction is exothermic in the forward direction, then it is endothermic in the backward direction. Remember it, this particular thing. Alright, next is effect of change of pressure. That also I said you, that if a reaction is taking place with a increase in pressure, means increase in volume, then the pressure should be less. The pressure should be less, we can say that. If a reaction is taking place with increase in number of volumes, then the low pressure will favor the reaction in the forward direction. Low pressure. Alright, like suppose, how can I explain this particular thing to you? Let me take an example, then it will be better. Like, let me take here, that is N2 gas plus 3H2 gas, then it gives 2NH3 gas, and the reaction is also exothermic in nature. That is, del H is negative, that means it is released. Now you can see here total number of moles is your 4 moles, and here the total number of moles is 2 moles. So for that reason you have studied in the lower classes or somewhere that this particular process is your Haber's process. This one is Haber's process, and the pressure is 200 to 900 atm. Very high pressure we take it. Why? Because the reaction is taking place with a decrease in number of moles, the decrease in volume. So higher pressure will favor the reaction in the forward direction. Higher pressure will favor the reaction in the forward direction, as the reaction is taking place with a decrease in number of moles. Alright. So in this way, if the number of moles or if the volume is decreasing, then the pressure should be high. Then the reaction will favor in forward direction. Consequently, if the reaction is taking place with increase in number of moles, for example, PCl5 gas gives PCl3 gas plus Cl2 gas. You can see here that is 2 moles, and here it is 1 mole. So this reaction should take place with a decrease in what you can say pressure. Here the pressure should be more, here the pressure should be less. But if a reaction is taking place with the same number of moles on either side, same number, H2 gas plus I2 gas gives 2HI gas. Here also 2 moles, here also 2 moles. So the number of moles remains the same. So here increase or decrease of pressure has got no effect on the equilibrium reaction. So that is, I can say the pressure is independent here. The pressure is independent. Whether you increase pressure, whether you decrease the pressure, there will be no effect on the equilibrium of a particular reaction, so to say. Alright, so this is about your increase or decrease of pressure, the effect of pressure. Now I have already said you about there is nothing but about the catalyst. I have explained to you all those things. Now generally Le-Chatelier's principle, what sort of question you expect? Alright, like this equation is given or this equation is given, and it will be asked to you that what should be the favorable conditions to carry out the reaction in the forward direction. So what you will say? If the concentration of PCl5 is increased, the reaction will favor in forward direction. If the pressure of the equilibrium reaction will be less, then the reaction will favor in forward direction. Now basically this particular reaction is endothermic in nature. Del H is what you can say positive, endothermic. So you will say high temperature favors the reaction in the forward direction, we can say that. Clear? So this sort of question will come. Alright, or it may come also, what should be the necessary conditions for the what you can say the better yield of ammonia in Haber's process? What should be the necessary condition? The necessary condition is that the concentration of N2 and H2 should be higher. Then the temperature should be less, because exothermic reaction it is, and the pressure should be high. Alright, an addition of inert gas at what you can say at constant pressure has got constant volume has got no effect on the equilibrium of reaction. Alright, but addition of inert gas at constant pressure will favor the reaction in the backward direction. That we don't want. Alright, because I said you better yield of ammonia, so that we don't want, that particular point. So in this way, if there is an equilibrium between ice and water, That's ice is melting to form water. That means ice is absorbing heat, endothermic, to form water. Then what should be the necessary condition? That the reaction should favor in the forward direction. Ice, water. Ice is the reactant, water is the product. So ice absorbs heat to form the product. The reaction is endothermic in nature. So first of all, the temperature should be more. If the temperature is more, then the reaction is definitely is going to take place in the forward direction. On increasing the pressure on this particular system, the equilibrium tends to shift in the direction in which the volume decreases. Got it? So volume decreases in which particular side? That is, equilibrium shifts to right, we can say that. That means the equilibrium will shift towards the water side. If the pressure will be more, then the equilibrium shift will towards the, what you can say, that is forward direction, we can say that. Clear? So increasing pressure favors the change of ice into water, more of water. Alright, so that is the ice melts. Clear? So in this way, there are several other questions we'll be getting it, like the Bose process, Haber's process, Ostwald process, many processes will be there, contact process, we can say that will be there, and the question will be asked, and what should be the favorable conditions. So you have to write basically 3 points: effect of concentration, effect of temperature, effect of pressure. You have to write these 3 points always. Alright, you need to write it down. Clear? So this is all about this particular chapter. Thank you.